Hello everybody and welcome to the Homework Helper first section 1.4. We're going to start with some exponent rules. The very first few, what we have here is we have the like base, so we have a base of 3, 7, 10, what have you. And whenever we're multiplying straight across, all we have to do is add our exponents together. So this would be the same as 3 to the 6 plus 5 or 3 to the 11. That's pretty simple. The more complicated ones I want to note is I want to note number 6 here, because this would be 6 plus a negative 3 plus, well, there's no exponent here, but really there's an exponent of 1, right? Everything is to the first power if it's not shown otherwise, so be sure to mark that. Additionally, I want to go to number 10 here, because number 10 has an interesting problem. Here we're dividing. So before when we multiplied, we would add our powers, so when we divide, we subtract our powers, 5 minus 8, which gives us a negative 3. But I want to note that we can only have positive exponents. And here we have a negative exponent. So to be able to process that, any negative exponent goes down into the denominator. So that 3, which started up top, would just move down. So this would be the same as 1 over 3 cubed, like so. So just be mindful of that if you ever end up with a negative exponent, that we can put it down underneath. Okay, for the set part, I want you to go through this step by step, but I had a couple questions already about it. When we're talking about an ordered pair, we're talking about x comma y, right, as we would plot it on a coordinate point. Now, for a function like this, this would be input comma output, okay, or maybe x comma f of x. So when it says write f of 16 as an ordered pair, well, 16 is where our x is. So this would be 16 comma whatever you get when you plug 16 into f of x. Okay, so just keep that in mind as you go through that. And then it has some questions about these two functions. And what you'll see with these two functions is you may get some similar answers, but when you look at them and you look at the relationship, you have to determine whether or not there's an inverse relationship here. Are we undoing one thing with the other? And hopefully you'll be able to see by the time you're done whether or not they're inverses or not. Okay, let's go ahead and turn the page. Try to turn the page. There we go. All right. For 16 through 22, what we're doing is we're trying to match whether or not or one function on one side with its inverted function on the other side. So this is going to require us to think about each of the steps it would take to make it inverted. So when I look at 3x plus 5, well, if I were to invert this, I would need minus 5 divided by 3, and then I would look around. Okay, here's minus 5, so that would be c, right? Minus 5 divided by 3, and you'll want to go through this step by step to see exactly how all of it works. So just be mindful of that. Use your rules. Watch out for the logarithms, okay? Logarithms here. So this means 5 to some power is x, okay? 5 to some power is x. Whereas, where's the other logarithm? 3 to some power is x. So we're trying to figure out 3 to what power is x, 3 to what power is x. So just be mindful of your log ones, because these will both be our log problems. But otherwise, just take your time with it. X to the 5th, well, we'd have to do the 5th root, so that would be g, this would be g, and just go through step by step like so. Okay, next. For the go, we're doing more fog and goff, f of g of x or g of f of x. And it wants us to find it both ways. We're going to plug both g into f of x and then f into g of x. So, for example, here, I'm going to take my g of x and plug it in for my x here, so that this becomes 2 times g of x plus 5. But g of x is all this stuff, so it's 2 times x minus 5 over 2 plus 5. That'll cancel out, giving me x minus 5 plus 5, or just x. So when I plug it all in, the only thing I get out is x. And so when this happens, when we have this pair of functions and it cancels itself out like this, that's how we know we have an inverse relationship. All right? That's how we know that we've inverted it. And so you want to make sure that that works for all of them. Then it's going to ask you to look at those look at all those functions and to see how, if they match with those problems. Okay, so which one of these match with each of these? Okay, so just be mindful of that and try to figure out which ones are which. Maybe plot a couple points, see which ones work. Okay, and then follow each of these steps here. It's just going to ask you some questions, but once you've done the work, the questions will make a lot more sense. So do that work, plug them into each other, figure out which ones are which. You know, these two are linear, these two are weird, so that'll help you kind of you know, process of elimination, figure out which ones are which. But from there, you should be pretty good on seeing making that connection piece between the equations and the graph and how the inverted relationships go into each other. All right, good luck on your homework, everyone, and I will see you next time.